Hello everyone and welcome. My name is Sheldon Kralstein, CEO of NAVX. We are very pleased to bring you the first in a series of informational webinars by world-class experts in distribution. Today's webinar on the high cost of using old technology will last about 1 hour and follow with a Q&A session by any of our speakers. The agenda for today will include a very brief NAVX value proposition. I'll give you an overview and the credentials of our speakers, and then we'll get to the main event, the high cost of using old technology, and that will be followed by our Q&A session. So let's talk about the value proposition of NAVX. NAVX is a Microsoft certified distribution solution built on top of the powerful Microsoft Dynamics ERP platform. NAVX enhances and supplements the rich functionality provided by Microsoft Dynamics with the important features that make NAVX a world-class solution for distributors and light manufacturers. NAVX is a complete distribution solution out of the box, requiring little to no third-party solutions or add-ons. The product provides comprehensive capabilities that include finance and accounting, inventory management, warehouse management, shipping and receiving, EDI, chargebacks and deduction management, purchasing and forecasting, customer service and order processing, profitability analysis and reporting, sales and broker commissions, promotional pricing, and so much more. NAVX is an easy-to-use solution that was designed around distribution processes and workflows by people who are experts in the industry and understand the pains and problems and challenges that today's distributors are facing. NAVX is offered through a family of certified partners in the US and Canada with deep knowledge and expertise in distribution. To learn more about NAVX for distribution and see comprehensive video demonstrations, please visit our NAVX video demonstration and training site at www.navx-demos.com. Let me introduce our two speakers today, John Schreibfeder and Dale Lanham. John is president of Effective Inventory Management, a firm dedicated to helping distributors, manufacturers, and large retailers get the most out of their investment in inventory. John has over 28 years of experience and has helped over 2,000 firms improve their productivity and profitability through better inventory management. He is a frequent contributor to over a dozen distribution industry publications and is the author of the National Association of Wholesale Distributors, guess right. A featured speaker at seminars and conventions throughout North America, Latin America, Europe, Asia, and the Pacific Rim, John has been awarded the title of Subject Matter Expert in Inventory Management by the American Productivity and Quality Center, and is an advisor and lecturer in Industrial Distribution Program at Purdue University. Dale Lanham is president of Lanham & Associates and a strategic NAVX partner. Dale has worked in the distribution industry for more than 30 years and has provided supply chain distribution solutions to over 1,600 companies and 80,000 users worldwide. Lanham has been recognized with numerous awards, including Microsoft's prestigious Partner of the Year. Dale will demonstrate how NAVX functionality can leverage the benefits articulated in John Schreibfeder's presentation. With no further ado, let me hand over the controls to John, and John will begin the presentation. This will take just a moment.
Thank you very much, Sheldon, and hello everyone. My name is John Schreibfeder. I'm president of a company called Effective Inventory Management. And I really want to take sort of a different tact. I know the title of this webinar is The Cost of Old Technology, the real cost of old technology. I would really like to rename it The High Cost of Old Technology, because you have costs running your business. We all know that. For example, you buy material for resale. You buy supplies. You have salaries. You pay your people. Other administrative expenses. We all know that you have expenses running your business. But if you are hampered with old technology, these expenses are too high. Now, I spent a good part of today reading about Amazon.com's entry into the industrial distribution marketplace. They're going to offer over 500,000 products online. Now, in order for you to compete with Amazon or any large entity, you have to be operating at the lowest possible cost, and you have to be as efficient as possible. If you are saddled with old technology, you are saddled with costs that are driving down your margins, driving up your cost of doing business. I'm going to refer to these as atypical costs. The biggest atypical cost is the costs of not providing good customer service. Poor service drives your customers to your competitors. Think about these things. How often do your customers receive the wrong quantity of the wrong item? Do you have stockouts of products that customers expect you to have available for immediate delivery? Those two things alone are going to drive your customers to your competitors. Last year, I visited one of our clients, a large aircraft manufacturer. I visited them on the last day of their fiscal quarter. They were in a panic. They could not deliver 2 airplanes to their customers. They couldn't deliver $60 million worth of aircraft because they didn't have $3.50 worth of fasteners. How long do you think the fastener distributor, who normally sold products to this company, remained their distributor? Probably not very long. They were probably thrown out after this episode. Think about it. If you don't deliver products to your customers when they expect them, they cannot service their own customers. And if they can't service their own customers, they're in trouble. They're going to leave you. And once you lose a customer, how much does it cost to win a customer back? Quite a bit if you can do it at all. But customer service isn't the only atypical cost that you have by utilizing old technology. We're going to look at dead stock and excess inventory, money tied up in products that your customers don't want. While you may not be able to use the money invested in those products to buy products that your customers do want. And if you have dead stock and excess inventory, it is taking up space in your warehouse, space that could be utilized to carry for you to store those products that your customers want you to have, that they expect you to have on the shelf in reasonable quantities. Now, old technology also wastes time. Time manually performing tasks that could be automated, that could be done faster with better technologies. Think about your buyers. If they don't agree with the recommendations produced by your computer system, what are they going to do? They're going to manually review the usage history of every item. This is a very time-consuming process. Is there a better use for their time? Absolutely. They can be dealing with exceptional situations. And if they are looking at every item, even those items that don't need attention, they're being overwhelmed with data. This can cause them to overlook a situation that desperately needs their attention. Going out to the warehouse. How much time do your warehouse people spend looking for lost material? Looking. I had a situation a few months ago. One of our clients, a metal service center up in the Northeast, they had 6 people. 6 people spent 4 hours looking for missing material in their warehouse. Think about it. 6 times 4, that's 24 hours, almost half a week, looking for missing material. These people could have been productive, but the company was saddled with this additional costs. Are your pickers efficiently filling orders? Do you have a system that's going to direct them to the right bin location for filling an order? The bin location that has the entire quantity that they need to fill the order. Does your system guide them to fill outgoing orders at the lowest possible cost to your company? How's that going to happen? When your fastest moving items, your most popular items, are stored in the most accessible bin locations. Now, let's start by looking at forecasting. Inaccurate forecasts due to old technology costs you a lot of money. Forecasting is the key to successful inventory management. When I talk about a forecast, I am talking about a prediction of the quantity of a stocked item that will be sold or used in the future. Okay, we need as accurate a forecast as possible, because if you have an accurate forecast, you can stock as little inventory as possible and still meet your customers' expectations of product availability. I want you to ask yourself, how accurate are the forecasts produced by your current computer system? I want you to use the equation that you see on this screen. The absolute value of usage minus the forecast divided by the lower of forecast or usage. Let's look at 2 examples. If you look at October, I had usage of 100 pieces, a forecast of 50 pieces. That results in a forecast error of 100%. If I reverse those numbers, as I do in September, I have usage of 100 pieces, a forecast of usage of 50 pieces, and a forecast of 100. I still get a forecast error of 100%. Being overstocked is as bad as being understocked. You have to understand that. If you're overstocked, your money is tied up in inventory that you don't need. If you're understocked, you're going to hurt customer service. You're going to disappoint your customers. Either way, it is a very bad situation. I want you to start by going back to your organization, looking at your A items, your most popular items. Calculate a forecast error using that equation. A high forecast error, as I said, means you are wasting time, you're wasting money. Inaccurate forecasts embarrass buyers. What do I mean by that? They get yelled at, either because they're out of stock or because they have too much inventory. What's going to happen when they get yelled at? They're no longer going to trust the system. They are only going to purchase products after making a visual inspection of detailed usage history, item by item, examining usage history. This wastes time. The average buyer deals with thousands of inventory items. This wasted time results in delays in issuing replenishment orders. What is the result of delays in issuing those replenishment orders? Poor customer service. You have delays in getting the stock receipts in. You're also going to have many situations where they overlook items that need their attention because they're overwhelmed with data. An example from one of our clients who implemented better forecasting policies and procedures, similar tools that you're going to see when Dale Lanham demonstrates his software a little later on in this webinar. The average forecast error for this customer, the average difference between the forecast and actual usage, dropped from 393.5% to 24.2%. That's a tremendous decrease. But you're going to say, so what? Well, the result was they could reduce inventory by 49.9%. Yes, I wish it had been 50%, but it was only 49.9%, while maintaining a 97.7% customer service level. What do I mean by customer service level? That is percentage of line items for stock products filled completely in one shipment by the promise date. Okay? How often did you have the entire quantity a customer wanted available for immediate delivery? Okay? The cost of bad forecasting involves old technology. Many old systems forecast demand using one simple rolling average. One formula is used to forecast demand of all products. There is no allowance for increasing or decreasing usage over time, seasonality, or other trends. There's no allowance for collaborative input from customers, salespeople, or management. And it is impossible to adjust or correct actual sales activity for situations that probably will not recur again in the future. If you have a high forecast error, you're leaving money on the table. Understand that different items in your inventory, even different items in the same product line, next to each other on the shelf in your warehouse, can have radically different patterns of usage. I took these 3 items from one of our clients' inventory. They're literally right next to each other on the shelf in their warehouse. As you can see from these graphs, they have radically different patterns of usage. They need different forecasting formulas, different forecasting methodologies. You can't rely solely on a rolling average forecast. Look at this example. If you look at the usage history at the bottom of the screen, do you see a pattern? Yes, of course. Usage sales have increased from December through June. That's obvious, but using a rolling average forecast based on the previous 6 months, this formula is considering January's history as much as June's in figuring out a forecast for July. The result? The forecast, represented by the black line on this screen, is falling far behind the pattern of usage. Usage in each month is represented by those blue boxes. Okay? If forecast is lagging behind usage, as we just saw, you will suffer from frequent stockouts of products that are increasing in demand. Think about it. Your salespeople are selling more of these products and they are frustrated because you're always out of stock. Frustrated salespeople, frustrated customers. Actually, in many cases, frustrated customers lead to frustrated salespeople, but in any case, you're looking at increased business for your competitors. But the forecast lagging behind usage is not the only problem. If the forecast is far exceeding actual usage, you have money invested in unneeded stock that could have been put to better use. This unneeded stock is taking up valuable space in your warehouse. Excess inventory often leads to dead stock. Why? The more you buy, the greater the chance part of that shipment will not be able to be sold. Demand for that product is going to taper off. The product will expire. The more you buy, the greater the chance part of that shipment may be damaged in your warehouse. Keep in mind, the longer it stays in your warehouse, the more times it is handled, the greater the chance it's going to be damaged. You want to enhance the replenishment process. Under old technology, a buyer is notified when the net available quantity of a product falls below manually set minimum quantities. When were those minimum quantities established? Probably when you turned the system on for the first time many years ago. In old technology, suggested purchase orders are prepared each day for every source of supply. This may sound good. You get a suggested purchase order for every vendor, but your buyers are going to drown in paper. They're going to drown. They're going to be overwhelmed with things that, quote, according to the system, need their attention. As a result, buyers don't often know that a critical item is out of stock until a customer or salesperson complains. And if a customer or salesperson complains, what is the buyer's response? Well, they're going to bring in a lot of the product to avoid getting yelled at again. They'll bring in a 6 or a 9 month supply. You are overstocked as a result of the stock out. This is bad. Let's replace the old technology with new technology and improve the process. In new technology, replenishment parameters are recalculated every month. The system continually monitors which supplier's items need the most attention. Okay? It's going to say this supplier needs to be addressed, their needs need to be addressed now. When the buyer finishes dealing with that vendor, the system will say, now this vendor needs your attention most. Buyers are immediately notified of impending critical stocking problems. Before you're out of stock, they're going to be told, oh, you are having unusually high sales in this product. You may need to bring in more inventory. In receiving, we don't have great productivity in old technology systems. Material storage locations are manually recorded in the system. This is a time-consuming process that, frankly, for many of you, often isn't done. Primary bin locations are manually updated in your computer system. But ask yourselves, do your warehouse people consistently run to the computer system whenever they move inventory and record the new location? Probably not. But even if they do, there's just a manual verification that material is being placed in the right location. And people tend to make mistakes. We've seen many warehouse workers make more and more mistakes as the day goes on. At 3, 4 o'clock in the afternoon, they are not at top form. They may put stock away in the wrong location, and you're faced with a treasure hunt to try and find it later on. And you're also depending on put-away people to properly record the location of excess and surplus inventory in the computer system. They're busy. They're rushed. Are they always going to take the time to note where they put material? In old systems, cross-docking. This is the process of filling orders when materials has just been received on your receiving dock. Cross-docking is difficult, if not impossible. The result is you're double handling material. You're having to put away in inventory before you fill orders for that material. Okay? Twice as much labor, greater chance of that material being damaged, and there is a big chance that the incoming stock may be allocated to the wrong customer. You receive it in, you've promised it to one customer, and it is inadvertently given to another customer. This is bad. Let's compare that to new technology, what you can gain by implementing state-of-the-art software like NAVX, barcode or voice recognition systems verify that material is being placed in the right location. The human element is taken out of the equation. The primary location is verified. It will beep nicely if they're putting it away in the right location. It's going to give them a warning message if they're trying to put stock away in an incorrect location. The system will also recognize, it will identify the best possible location for surplus or excess inventory. These locations are going to be accurately recorded, so when you need that material, it can be easily found. Cross-docking is facilitated as quantities of products needed for outgoing orders can be identified and segregated on the receiving dock. You are filling orders, outstanding orders, current orders, back orders for products as soon as the material hits your dock. Not only are you not double handling material, meaning you're saving a lot of money in not handling the material twice, you're not only ensuring that the right customer gets the right product, you are also filling orders faster. You're going to have a much higher satisfaction level from your customers. Picking productivity also improves with new technology. Let's look at a typical picking situation using old technology. Items are picked in what we call presentation sequence, the sequence that your customers ordered the products. And when your customers order products, they aren't building their list based on how the products are located in your warehouse. They're ordering them as they think of them, or the order on their list. The result? Pickers often have to backtrack to locate the next item. You have a lot of what we call deadhead time. People walking around your warehouse, wasting time without any material in their hands or on their cart. There's no verification that the right item is being picked. How often have your customers received the wrong item? Are they happy? Absolutely not. Actual locations of individual pieces are not known due to what we call paperwork float. In new technology, as we're going to see, we know where every piece is at all times. You can go out and find it. Old technology, we have no idea when material was taken out of a bin to fill an order. Your on-hand quantity actually isn't decremented until you verify the invoice, which is a data entry process, which in fact can lead to more problems. Even if your warehouse workers are near perfect in the way they handle material, if the data entry operator, the person who verifies what was shipped, if they make a mistake in the process of verifying, say they hit an extra zero, you have a problem. A customer may be billed for 100 pieces rather than 10 pieces. Are they happy? Absolutely not. You're going to hear about that. But are you going to hear if a customer is billed for 10 pieces rather than 100 pieces? That's a good question. New technology solves this situation. The number of times each item is picked is tracked to ensure that material is located in the most advantageous places in your warehouse, the most advantageous bin locations. Our idea in a good warehouse management system is to locate material in such a way as to minimize the cost of filling orders. Okay? Scanning, voice verification ensures that the items ordered are actually being picked. Okay? The customer is not going to receive the wrong product. Technology ensures that The system is immediately notified of all material movement. Using a good warehouse management system, as is available in NAVX, the quantity in your computer system should always agree with the quantity that is actually on the shelf in your warehouse. Data entry errors are significantly reduced, maybe even eliminated. Why? Because we don't have to have a clerk typing in quantities that were shipped in order to invoice the order. The shipment verification is done with barcoding, is done with technology. The chance of a mistake happening are reduced tremendously. Okay? Now, under old technology, salespeople, buyers, management are suffering. They are victims of paper pollution. Before I did this webinar, I just looked at the records sent to me by a customer. The only inventory records he could send me were detailed transactions. Every shipment, every stock receipt, every transfer. I'm trying to make sense out of this large pool of data. I can't make sense out of it. It's too detailed. I'm drowning in paper. I'm drowning in data. This is time-consuming. You can't identify situations that need your immediate attention if you are overwhelmed with data. It's difficult, if not impossible, in these situations to develop long-term plans. New technology, the best new technology, like NAVX, deals with what we call exceptional reporting. You know, it's strange. In most cases, no more than 10-20% of your items in any month need a buyer's attention. The rest of them, the system can handle it by itself. But those 10 or 20%, each and every one of them has something going on that needs the buyer's attention. Maybe we have unusual sales or usage. Maybe customers are buying a lot more. Maybe a location is selling a lot more. Maybe we see unusual usage with specific items, unusually high or low sales. Buyer, seeing this, can research and figure out what is going on. We don't want them to be shoveling data. Good buyer is going to put on a Sherlock Holmes investigator's hat and research items, research situations that your system brings to their attention. They'll see abnormally long or short lead times. They'll contact the vendor and determine what's going on. Is this unusual or the start of a new trend? They'll identify inventory, customers that fail to meet profitability and other objectives. They'll also identify, the system will highlight opportunities to increase sales, to increase your profitability. So, in summary, how much is old technology costing you? Well, think about it. The inability to completely fill orders to meet your customers' expectations. Wow, that's a big cost. You disappoint customers, you lose customers. You have a hard time getting them back. Lost productivity due to necessary busy work, sorting through mounds of data, looking at the usage history of individual items, overlooking situations that require immediate attention. You're drowning in so much paperwork, you can't see the critical item that's crying for help because you are out of stock or running out of stock. Okay? And the lack of meaningful information causes you not to be able to identify current and future profit opportunities. As I said when we started this session, this isn't the cost of old technology. This is the high cost of old technology. Good systems are going to pay for themselves in greater profitability, decreased operating costs in a very short period of time. Now I'm going to turn this back over to Shelton, and he's going to introduce Dale Lanham, who has some good software that's going to solve these problems. Thanks.
Thank you, John. Great presentation and very informative. Dale, I'm going to turn the controls over to you, and you should have them at this point.
Okay, thank you very much. Thank you, John and Sheldon. It's always good to hear John make presentations. I do that quite often, and we've worked together for a lot of years, and I think he has some very good information relative to technology. What I would like to do is to spend a few minutes to show you or talk a little bit about technology in a specific area of forecasting and replenishment, and I'll spend just 4 or 5 minutes talking about the overall high level, and then we'll get into a demonstration. So I like to start with results. So let's assume that you have $20 million in inventory, and let's assume very conservatively that you're able to reduce that by 20% over time, maybe 2 or 3 months, maybe 6 months. And then let's say that you have a 20% carrying cost, and that's typically about what most distributors run with these days. So $4 million times 20% shows a savings of $800,000 in carrying cost. So it's a real important opportunity to use technology to reduce inventory, improve bottom line, and those kind of things. Along with that, along with managing your inventory and forecasting well, you get increased sales, typically, simply because you reduce stock outages, and you get better customer satisfaction. The other thing is you lower transportation costs. Often this is forgotten. If you buy the right quantities at the right time and deploy them in the right warehouse, those transportation costs are much lower than you would normally have. Okay, the next thing that we try and do as a highlight, and I'll show you an example of this in the system, is to find where the good, bad, and the ugly inventory is. One of the ways that we do that is basically to look at the total inventory, and we analyze this every day. We look at the inventory that you need. We look at the inventory that is in excess of that need, and then something that's out past this surplus inventory that we're talking about called excess. The best way to describe this is if you're dealing in electronics as an example and you have more than 6 or 8 months worth of inventory, it's pretty good idea that you're going to have an obsolete item before you can move it, right? So that would be our excess calculation. And then surplus would be I'm carrying more inventory than I need, but I'm probably not in danger of not selling that. So I just want to give you a real high level of forecasting replenishment system. Basically, here is the historical usage. Everything starts with that. You need to be able to adjust that. John talked a little bit about that. Then you need a best fit formula approach. So we apply a best fit formula of 18 formulas against historical usage, and we end up with a statistical or history-based forecast and the total forecast there. Then we want to start doing things like making adjustments to that. Maybe we know something the system doesn't know or couldn't know. So let's make adjustments to the forecast, and let's track those adjustments. Anytime we talk about adjustments, it's really not changing a number. It's actually adding a number to the current one and showing the result. So we can actually track adjustments that were made anytime, anywhere, and who did them. And then a forecast summary. I may want to roll my forecast summary up and then make adjustments at group levels, or at product category levels, or product line levels, sub-product categories, those kinds of things. The next thing is collaborative. John mentioned this as well. So for those large customers that you can collaborate with, what we would like to do is to either create a forecast and send them, or have them actually give you what they think they're going to buy, have some kind of a discussion with that customer, and then get the right numbers into the system. Okay, we then isolate that customer and make sure that we're just looking at that information and compare what that customer said over time to how accurate that is, and then we can figure out whether or not that's a good process to go through. The next thing is sales promotions. One of the greatest things in the world to increase sales is promotions. One of the worst things that happens is quite often that that sales promotion history goes in, and you turn right around and replenish too much of the inventory. So what we need to do is adjust the forecast up in the future and adjust the historical usage down in the past as a result of the promotion. Then 100% accurate forecast, and I say this quite often, 100% accurate forecast really doesn't solve the whole problem. 50% of this is actually the replenishment side. So basically, this forecast goes two places. I've got 15 periods here, but we actually go out 52 periods, and so typically about 15 months is as far as is practical to go out, though. So we take for a production item, so light manufacturing, maybe you're repackaging something, changing its form a little bit, those kind of things. So basically, we're forecasting that finished good and or a kit, and we are then driving demand down into the replenishment side based on the forecast of the finished good, not based on the consumption of the components. If you base it on the consumption of the components, then you're likely to overstock or understock when you change the makeup of that product. So then the sales of that item would go through into the replenishment side in this in the middle of the screen here. The end result is expected inventory, time-phased expected inventory. So we're looking at on-hand inventory, and every transaction in an ERP system has an expected date other than on-hand inventory because you already have that, right? So we're expecting what goes out, what comes in, when it goes out, when it goes in, an exact date. We actually then go and drill down to the day when we're looking at the replenishment model, and we're taking into consideration everything that will happen prorated down to the day. So we prorate the forecast, the maybe over-demand, over-consumed forecast or under-consumed forecast, but then production orders that are happening and potential purchase orders coming in, transfers to other warehouses, those kind of things. So suffice to say, it's just a net expected inventory. Then we analyze lead time. Very, very important. Lead time's longer, you're going to have to commit to more inventory, or at least order quite often there. Then vendor targets. If I'm importing from China, and most of you probably do some importing from some country with long lead times, we need to look at container level imports probably. You might also domestically have a minimum dollar amount, something of that sort. So what we're actually doing is we're creating a suggested order, and then we're comparing the vendor targets that you've set in the system and telling you whether you've met those or not. The next thing is surplus inventory. It's real common in a multi-warehouse environment to have to need inventory in one warehouse, so we actually are getting ready to create a purchase order, and all of a sudden, now we have surplus inventory, but we don't know it, right? So the whole idea in the suggested order is to actually tell the user, you're about to buy 200 of these, maybe there's some surplus somewhere, and give them the opportunity to transfer that product. So the end result of the suggested order could be a transfer order as well as a purchase order. So basically, this is a kind of a high level of the way system works. I'm going to hit just a couple of more points. Distribution requirements planning, or DRP. One of the things that's really technology focused, because you couldn't do this 10 years ago probably, is actually to time phase inventory and also roll the forecast into the future as far as we do these days. Okay, I was making a presentation to I guess 80 or 90 distributors about a year ago, and I asked the question, how many of you import at least some products? Almost every hand in the room went up, and that tells me that older technology that deals with min-maxes and weak supply and things of that sort really doesn't address that very long lead time that you end up with in the import scenario. Another thing is hub and spoke. How does hub and spoke work? We actually roll up the history that has happened in the lower level warehouses to the top level. We buy at the top level, and then we push product down in smaller increments. So we're less likely to overstock a branch warehouse or understock a branch warehouse in that case. It's a very important scenario there, and as John can tell you, that's probably a 2-day presentation of how to figure out what to do with that. The next thing is actually inventory balancing. So let's say I have the inventory where I think it is. I need to run an analysis and say, is each of those items where it needs to be? And the system should be able to recommend moving some from one warehouse to another if that needs. I have a need in one place and a surplus or excess in another. Maybe you should move it.
Okay, let's start the demonstration now. And you'll see the buyer's role center here. It's really about 60 or 70% of the things that you would do on a normal daily basis as a buyer. And let's start first with the buying calendar. And the buying calendar basically is a list of the vendors and the warehouses that you might be responsible for. Again, the role center basically is filtered based on your user ID and your responsibilities and what warehouses you might be responsible for, what vendors you might be responsible for. So let's just take a look at a suggested order. This suggested order would typically be created overnight, and it would actually take a look, or the system would actually take a look at all of the items for each of the vendors and then make suggestions of what you might need to buy. These can be run over and over during the day if you want to refresh that, because if it's 4 o'clock in the afternoon, I can guarantee you that you would do something a little bit different than you would at 8 o'clock in the morning, because the system is real time. We're actually seeing large sales orders that might come in that would change your buying pattern or change the quantity that you would buy and things of that sort. So again, real time, based inside Dynamics NAV. So let's take an item here, and one of the things that we spend a lot of time on is actually something we call visibility. So basically, if I tell you that you need 48 of a product in this case, and by the way, I'm suggesting you buy 90. Why am I suggesting that? So let's take this 48 number and drill down a little bit and see if we can figure out why that's happening. So I'm going to actually open the forecast view of this item. And this is a forecast screen, and it will go out, I think I have the system set, yes I do, for 15 periods. A period can be anything that you want. It can be weekly, can be monthly, or you could run actually 13 periods if you want to match accounting periods or something of that sort. So if we look at the top part of this view here, we're actually looking at January 2011, February, March, and so on. For demonstration purposes, the current day today is January 27th, 2011 in this demo database. So we're running as of that date. And if I look at this, I'll see January has a forecast going forward here. There's some forecast adjustments, customer collaborative forecast, demand, consumed. And I'm going to go back and review these numbers in a minute. But basically, as a buyer, when you come here, you're concerned about one number. On the lead time horizon, what quantity of inventory do I need as a minimum? And it says minus 48. So that matches, again, this number back here that says you need 48. So I'm going to come back to this forecast view again. And again, I'm going to spend a little bit of time here so you kind of understand how the forecasting works and how it is tied into the replenishment side. As I said earlier in the PowerPoint presentation, forecasting is only about 50% of the job. If you have a 100% accurate forecast, then the replenishment side if you take that data and put it into most systems, you would probably find that you're still making some buying decisions that are inaccurate. So we spend a lot of time in the replenishment side as well, looking at time-phased expected inventory, the forecast, prorating it, and things of that sort. And that's what I'm about to show you here. So again, the forecast going forward here is a historical forecast or a statistical forecast based on historical usage. So let's look at the forecast adjustment here of 50. If I drill down, I'll find that I have increased this forecast by 40. I've decreased it by 10 and increased it by 20. The reason for this, if I stretch the screen a bit, you'll see that the adjustments were made by Dale on these days and this time. So basically, any adjustments that are made in the system actually have a date and time stamp on them, and so we're actually not adjusting any number in the system. We're actually adding transactions to increase that quantity or decrease that quantity. Also notice there is a promotion code here. So this is as a result of a future promotion, and this one is just an adjustment that was made. And again, we know who did that. So the net of this is 50. So my total forecast then would actually include one other thing, and that's a customer forecast or a collaborative forecast. So if you have large customers that you are collaborating with, we actually bring this data into the system. We can import their data, or we can actually generate a collaborative forecast for them for that particular customer and the items that they buy. In this case, we are collaborating with two customers, customer 10,000 and customer 30,000, and you'll see that these are the quantities that we expect those customers to buy. So we've started out with 9 for this one and for customer 10,000, and then increased it by 16. And so on. So you can see again who made that change in the date and time. These adjustments, as opposed to the forecast adjustment, are made in the customer collaborative subsystem in the system. So there's a whole new user interface that just facilitates the customer collaborative forecast. So my total forecast then is 16.9 or 17 plus 50 plus 35. Then I really need to monitor my demand and consumed, and I'm sure anyone who's been involved in the forecasting world will understand what a consumed forecast is. So if I have a forecast of 100 and I sell 110, I've actually over consumed the forecast. So in my case, I have 49 that I've shipped so far this month. I can drill down and see that. I can also drill down on demand, and demand is represented in most cases by sales orders that need to ship in this period. So let's look at the demand here of 37. If I drill down on this demand, I'll find that I have 2 sales orders, and the expected ship date is January 5th and January 8th for a quantity of 20 and 12. I can actually click on this button and actually see the original sales order. So again, integrated with the forecasting and replenishment system. It's quite unique. Most forecasting and replenishment systems are built outside the ERP system. This one is actually built inside, and so we're actually getting updates real time as a sales order is created in the system and shipments are made and things of that sort. So if my demand and consumed had exceeded the forecast, the total 3 lines of the forecast, then I would have a forecast adjustment. In my case here, I don't need that. Okay, the forecast adjustment would be increased to at least equal demand and consumed if that was larger than the forecast. I also have a mechanism that says let's take the remaining forecast times the number of days and increase that by some percentage as well. And that's a deeper subject than we have time to get into at this point. So my total forecast is 101, or actually 101.9 or 102. The consumed forecast, or the shipments, are 49. So then my accumulated forecast is 52.9. So I need 52.9 between now and the end of the month. If I look at February, I'll see I have a forecast of 83, and then if I add 52 and 83, a total 136, plus 69 is 205, and so on. So it's rolled forward. Anything that changes back here will change the numbers dynamically, by the way. So if I look at this and I scroll down just a little bit here, notice that I need 52.9. I have 103 in inventory. I have some transfers here. So let's drill down and look at this. Again, real time. I'm transferring out 12 and in 8 for a net -4 in this particular warehouse. Here's a PO that's coming in February. I can drill down on that and see it's coming in on February the 27th. I could then also go back and look at that purchase order itself. Then I realize that the majority of the people on the presentation today are distributors, but many distributors do a small amount of production, some repackaging and things of that sort. So if you have production orders, then those production orders would be showing here to consume inventory, and also future production orders that might be planned into the future. And then components could be a result of a production order, component demand, or a kit component demand. So everything is considered that can affect this item in this warehouse. My net inventory position is 46 at the end of the month, -17 in the next month, and -90 here. So notice that I have a lead time horizon. I mentioned this in the PowerPoint presentation, where a lead time horizon is today plus lead time days, review cycle days, and safety stock days. If I add those days together, it gives me March the 12th, 2011, and if I prorate the forecast and the time-phased inventory, I need at least 48 at the end of this time. Okay? But notice that we're suggesting 90. I want to drill down here and show you something else that we do in terms of visibility, and this is the calculation lines. So if I look at this, I'll notice that my lead time horizon is 312. I need 48. We just verified that by looking at the forecast. But it's saying here that the economic order quantity calculation is saying you probably need to buy 84. Now, anyone who's familiar with this is the Wilson method of EOQ. Anyone who's familiar with the EOQ formula will probably understand that basically what happens is the EOQ formula is trying to tell you the most economical thing to do when you're buying product. So a lower cost product you'll buy more of, a higher cost product you'll buy less of, and all of it's based on the forecast and things of that sort. So the system says, if I were you, I would buy 84 of these based on the carrying cost and those kinds of things. And then if I look at this, it says, hey, I have an order multiple of 10. This just shows an example of having order multiples, order minimums, could have a purchase unit of measure as well. So I'm actually, in this case, going to say that we need 84, but we're going to round it up to 90 based on the order multiple. So then the order quantity that we're suggesting is 90. So as a buyer, you could click a couple of times in a few seconds and make this determination. I've gone through the explanation of how everything works there. But if you disagree with that, and keep in mind one of the things that I said also in a PowerPoint presentation, this is a tool. And we don't want to disengage the brain. We want you to look at this, look at the reason that we made these decisions, and if you disagree with it for some reason, you know something the system doesn't know, then you can make a change, and you could actually change this quantity here if you wanted to. Okay? A couple of other things that I also mentioned in a PowerPoint presentation is surplus inventory. So I have some surplus inventory available, and the reason for that could be that I have more inventory than I need in other warehouses. Okay, so let's see what that is going to show here. So if I look at the surplus available screen, it shows me that I have a surplus outstanding of 2 in warehouse 3 and 52 in warehouse 6. Okay, so I can make a determination to transfer part of this inventory because this amount of inventory, the outstanding surplus here, is more inventory than that warehouse needs. We don't know, we don't look at how much they have and pull that inventory. We're actually showing you how much they have more than they need through their lead time or through their replenishment cycle. So let's just make a determination here that we're going to transfer, let's just say 40. So I'm going to transfer 40 from that warehouse, and I'm going to buy the net. So 90 minus 40, and I would buy the net from the vendor. So there's a number of things here also on the right-hand side that shows, and I'm going to come back to this later on, but it shows you the total or the summary total of this suggested order. So let's say that we have reviewed this suggested order and decided this is exactly what we're going to do. We're going to transfer the 40, we're going to buy the net of that, and we're also going to buy the other recommended quantities. So the first thing I would do is actually create a transfer order. And it will actually create a transfer order for that 40 that we just looked at. And now I'm going to create a purchase order. And if I say yes, it will actually create my purchase order for these quantities. So then if I go down and look at the history, or posted documents, sorry. Look at the posted documents, and I open this suggested order. Notice this is the 48 and the 90, or the 90 that the system suggested that we needed in this location or need to bring in, and here's the 40 that we transferred. I could also come back and say, let's see what happened. Here's my transfer for that item from AFP 6 to AFP 1 in a quantity of 40. Okay, then let's look at the purchase order. If I drill down on this purchase order, again, this is the one that we've just created. Notice that I've purchased 50. So the net of 40 to 90 is 50, of course. So that's what we purchased for that particular vendor. So this basically shows you how you can actually create a suggested order and review it. Now, one of the things I'd like to do, I'm going to take a couple of more minutes here and just look at the transfer order. I'm going to delete the transfer order and a purchase order, because if I didn't do that, I couldn't create another one, and I want to actually do that. So I'm actually going to delete this transfer order. Say yes, and we'll go back and create another suggested order in a minute. I also want to pull up the purchase orders and delete those. Actions, delete, and yes. Okay. So now if I go back to the Roll Center, this one thing I'd like to do now is I'd like to show you how you can create the suggested order during the day. So I would actually just click on this, say yes, it reviews all of those items, and I'm going to get a suggested order identical to the same one that we started with, because I've deleted that transfer and purchase order. So once it finishes and I open the suggested order, I'll see that here's the 48, and the 90, or the 48 that we absolutely need, the 90 that we've suggested. Okay. Notice on the right-hand side, I have a target amount, a net amount. So basically I have a target of net weight, gross weight, dollars, and volume. And so if you're trying to reach a container level or something of that sort, then you would want to take a look at this. So I'm actually, let's just assume that I need $45,000 or so dollars instead of this target of 35 here. So I want to increase that suggested order. I could just increase these quantities. I could increase by a percentage, but the thing that I'd like to do is to say, let's push vendor lead time. So let's add X number of days to this, to the amount that we're buying. So I'm going to add 10 days to it. I'm going to create a suggested order. And when I do that, I'll see at the bottom what my total is. And I can do this multiple times until I get the suggested order the way I want it. So if I'm trying to fill a container, truckload, reach a minimum dollar amount for a small vendor, something of that sort, I could do that. And here's the $45,000 that I was trying to reach. I knew that that would do that in the demo, but you could run it multiple times to actually create that suggestion. So if I go back and look at the suggested order one more time, notice that it says you need 70, but we're going to suggest that same 90. Okay. If I look at the calculation lines, it shows me that I've pushed vendor lead time days by 10. My new lead time horizon is a different date than the base quantity that I need is a different number, and so on. Okay, so it basically is showing you how you can reach, if you will, or push and buy additional inventory for a vendor. Okay, so let's go back to the role centers. There are 2 or 3 more things that I want to show quickly. One is alerts. There's some things that happen in systems, and because we're in a real-time environment with the ERP system, it's really important to give the user alerts and tell them that something strange is happening that we need to take care of. Okay. In this case, this item 1705-450 here shows a stock out on January 27th, and it goes further negative going forward. And by the way, these increments typically are 7 days. We set this in the system, whatever that increment days we want to have. So in other words, it says on 127, I need 44, another 7 days I need 49, and so on. Notice that on 319, I have a date here on 319 that shows that the inventory outage is projected to be over because I have a purchase order coming in close to that 319 date. Now, what's really interesting is that a lot of systems would not tell you about these numbers of weeks here that you're going to be potentially out of stock, because I have enough on order to cover my forecast and my need. But what you have here now is an alert that says before that you're going to be out of stock. What is that? 6, 8 weeks potentially. So if you have a long lead time, you could actually be in this particular situation. Some other things here, late purchase orders and things of that sort that are on the alert worksheet, all different things. Here's an example, and normally we wouldn't have created this, but maybe someone created a manual purchase order where we have 433 quantity as surplus, more than we really need, but we have 20 on order. That's a purchase order or a purchase order line that we probably should cancel, as an example. So it's just an example of some of the alerts and things. I want to show you, and we talked a little bit about the good, bad, and the ugly are the good inventory, the bad inventory, which is actually surplus inventory, and then excess inventory. So let me go to the departments menu here, and we'll look at something called surplus and excess inventory value. This is updated every day. And so what we're actually creating here is we're actually looking at this particular company, and there's a small number of inventory items here, so it's not representative of, say, $20 or $30 million in inventory. But you can see that the good inventory is much larger than the other two. But what we also can show you, if you click on this, the dollars that are invested in each item that are based on the target that I needed. So my target amount, in this case, I needed the $321.75 worth, but I have a surplus of 2 and an excess of 5. So I have $71.50 and $178.75 invested in inventory, more than what I really need. Okay, and of course this is summarized at the warehouse level and at the company level and various other levels if you want to do that as well, if you want to run the report for that. So basically what we're trying to show you is where your dollars are invested in inventory. Many systems do a pretty good job of optimizing the inventory, but if you get out of shape on an item, there's not a lot of times there's not a good way of actually analyzing where my inventory is growing, where do I have the surplus, where do I have the excess inventory, what can I do about it, what can I do to reduce the inventory and therefore reduce the outlay of inventory or outlay of dollars for inventory. There are a number of other things. I'm actually running out of time here, so I'll end the demonstration now. But I would certainly encourage you to look into the system and take some of the principles that John mentioned and take a look at those and also maybe get a deeper demonstration of the forecast and replenishment in Dynamics NAV. Thank you very much.